Again, welcome to our channel, guys. And of course, this is Teacher Bong Fontanilla saying, "Smile is a curved line that sets everything straight." This time, we are going to talk or discuss about zeros of a polynomial function. But of course, before anything else, please like and share. Do subscribe our channel. Click the notification button for automatic update for upcoming video lessons or uploads. Okay, thank you. So going back, our topic for today is all about zeros of a polynomial function. So what is these zeros of a polynomial function? When we speak of zeros of the given p of x or polynomial function, it is simply the value of x that will make the polynomial equal to 0. That is, p of x is equal to 0. So whatever the value of x that will make your polynomial equal to 0, that is what we call the zero of that polynomial function. Okay, let us try to consider our first two examples. Find the zeros of the given p of x. Number 1, p of x is equal to x minus 3 times x plus 2 times x minus 1 times x plus 1. In this particular example, it is very easy for us to identify or to solve the zeros of the given p of x. Why? Because our p of x is already expressed in terms of its linear factors. So all we need to do is we will simply equate the linear factors to 0 and solve for x. So we have x minus 3 times x plus 2 times x minus 1 times x plus 1. So equate it with 0. So since these are already linear factors of the given p of x, so we are going to equate individually the binomial factors to 0 to solve for x. So for the first factor, we have x minus 3 equals 0. Solving for x, we have x is equal to 3. Then from the second factor, we have x plus 2 equals 0. So we have x is equal to negative 2. Then for the third, we have x minus 1 equals 0. So x is simply equal to 1. Then for the last, we have x plus 1 equals 0. So x is simply equal to negative 1. Okay, thus the zeros of the given p of x, x minus 3 times x plus 2 times x minus 1 times x plus 1 are 3, negative 2, 1, and negative 1. So we have 3, negative 2, 1, and negative 1. So these are already the zeros of the given p of x. So take note that if the p of x is expressed in terms of its linear factors, then we can readily solve or immediately solve for its zeros by simply equating the factors to 0. Then solve for x. Okay? Let's go to number 2. you are given p of x is equal to x plus 2 quantity raised to 3 times x squared minus 9. So look, it is expressed in terms of its factors, but our x plus 2 raised to 3 can be written as x plus 2 times x plus 2 times x plus 2. And our x squared minus 9, if we may recall, under factoring, so this is a difference of two squares. So how do we factor out difference of two squares? That is simply the sum and difference of the square roots of the two quantities. So x squared minus 9, that is simply x plus 3 times x minus 3. Then equating this to 0, then we are now ready to solve for the zeros of the given p of x. X plus 2 quantity raised to 3 times x squared minus 9. So equating each of the factors to 0, so we have x plus 2 equals 0. Solving for x, x is equal to negative 2. Since x plus 2 appears 3 times as factors of p of x, our root negative 2 has a multiplicity of 3. Meaning to say, this negative 2 is taken 3 times as the root of the given p of x. So multiplicity of 3. That means to say, this negative 2 as root of the given p of x is taken 3 times. Then we have x plus 3. So we have x plus 3, equate it to 0. So x is equal to negative 3. Then the last, x minus 3 equals 0. So we have x is equal to 3. So therefore, the zeros of the given p of x, x plus 2 quantity raised to 3 times x squared minus 9 are we have negative 2 multiplicity of 3. Then we have negative 3 and 3. So there are negative 2 3 times, so 3, 4, 5. So there are 5 roots of the given p of x. Okay? So again, I would like to emphasize when we say multiplicity of 3, our 0, negative 2 appears or it is taken 3 times as the root of the given p of x. Why? Because our factor x plus 2 is taken 3 times as factor of the given p of x. That is x plus 2 times x plus 2 times x plus 2 times x plus 3 times x minus 3. Then equate it to 0. If you are going to solve for x individual binomial factors, so you will get negative 2, negative 2, negative 2, negative 3, then 3. That's why we have negative 2 multiplicity of 3, negative 3, then 3. Okay? So I just hope that you did follow. Nah? So let us try to consider other examples. Okay guys, let us try to continue. So let us try to consider this. Solve for the other zeros of p of x given 1, 0. Say p of x is equal to x cubed plus 8x squared plus 19x plus 12 and 1, 0 or x sub 1 is equal to negative 1. Since x sub 1 is equal to negative 1, that means to say one factor of this p of x is x plus 1. That's one of its linear factors. So how shall we solve for the other zeros? To solve for the other zeros, we are going to apply or use the synthetic division. So the synthetic division is very much useful if we are to solve for the zeros of polynomial function. Because from there, we can also extract the quotient, and from the quotient, we can again factor that out to solve for the other zeros of the given p of x. So recalling our synthetic division, since 1, 0 is negative 1, that means to say that's 1, 0, or the c is negative 1, or the factor of your p of x, one factor is x plus 1. So we have negative 1. Applying now your synthetic division, consider the numerical coefficients. So no problem, it's complete. 3, 2, 1, then your constant term there. So the numerical coefficient of the leading term is 1. Next term is 8. Then next term is 19. Then we have 12. Okay. So bring down 1. We have 1 times negative 1. We have negative 1. Then 9 plus negative 1 or 9 minus 1, that is simply 7. 7 times negative 1, we have negative 7. Then 19 minus 7 or 19 plus negative 7 is 12. And 12 times negative 1, negative 12. So you can observe that the remainder is 0. That means to say our negative 1 is really a root of this p of x, because x plus 1 is a factor of this p of x. So how about the other factors? Because we are going to get the other factors for us to be able to solve for the other zeros of this p of x. From our synthetic division, from the values here, this becomes now the numerical coefficients of our quotient. That is dividing x cubed plus 8x squared plus 19x plus 12 divided by x plus 1. The result would be taken from here. So since the leading term or the degree of our p of x is 3 and the degree of our divisor is 1, so 3 minus 1, the degree of our quotient will be 2. So we have x squared 1, x squared, then 7, positive 7, so we have positive 7x. Then we have positive 12. So this is now the quotient. Yan. So this is our p of x, and if it is divided by x plus 1, the quotient would be x squared plus 7x plus 12. So look, that's how important the synthetic division is. It will give you the quotient when p of x is divided by x minus c, or a binomial. So from the quotient x squared plus 7x plus 12, take note that it is already in quadratic form or quadratic trinomial. So if it is a quadratic trinomial, so it is now easy for us to get or think of the linear factors. So paano tayo mag-factor dito? We have 12. What are the factors of 12? Wherein, if you are going to sum this, it will give you 7. So 12 or positive 12, that is 3 times 4. And 3 plus 4, it will give us 7. So we have x. Ayun. So 12, that is 3 plus 4. So plus 3 and plus 4. So your x plus 3 times x plus 4 are now the factors of x squared plus 7x plus 12. Then from these factors, we can now solve the other zeros of the given p of x. So we will simply equate it with 0. So solving x from each of the factors, we have x plus 3 equals 0. So x is equal to negative 3. Then x plus 4 equals 0. So x is equal to negative 4. There. Thus, the other zeros of the given p of x are, so x sub 2 could be negative 3 or it could be negative 4. So walang problema. Now, pwedeng negative 4 mauna, pwede rin negative 3 ang mauna. So we have negative 3, then x sub 3 is negative 4. Or the zeros of p of x, x cubed plus 8x squared plus 19x plus 12 are negative 1, negative 3, and negative 4. Okay? So that's how we get the zeros of the given p of x if it is expressed in terms of this. And 1, 0 is given. Okay guys, so let's take our another example. This is already number 2 for letter B. So that is solve for the other zeros of p of x given 1, 0. So you're given p of x is equal to x raised to 4 minus 2x cubed minus 7x squared plus 8x plus 12. And 1, 0 is 2. So from this 0, that means to say your x minus 2 is one of the linear factors of p of x, or your x raised to 4 minus 2x cubed minus 7x squared plus 8x plus 12. So to get the quotient without applying the long method of division, we are going to apply the synthetic division. So we have 2, okay, our numerical coefficients. So numerical coefficient of the leading term, 1. The next term, negative 2. Then we have negative 7. Then we have 8. Then we have 12. So 4, 3, 2, 1, 0. By the way, if the degree of the, whatever the degree of the polynomial, that is also the number of zeros the polynomial have. So if the degree is 4, that means to say that there would be 4 zeros of this p of x. Okay, applying the synthetic division, so we have 1 times 2 is 2. Then negative 2 plus 2, that is 0. Then 0 times 2, we have 0. Negative 7 plus 0 is negative 7. Negative 7 times 2, that is 12. Negative 14. Then 8 minus 14, that is negative 6. And negative 6 times 2 is negative 12. 12 minus 12, that is 0. So the remainder is 0. Of course, because 1 root is 2. Therefore, x minus 2 is one of the linear factors of the given p of x. So from here, actually we can continue the synthetic division. So this is already our x sub 1, that is 2. So we are going to have a trial and error. How about if we are going to divide your p of x by x plus 2? So therefore our c is negative 2. So is x plus 2 a factor of this p of x? So let us try to find out. So from here, yan na, ituloy na natin. So we have from x plus 2, we will be getting negative 2. Okay. So let us check. So using the synthetic division again, ituloy-tuloy na lang natin. And let us try to find out whether this x plus 2 is a factor of this p of x. If x plus 2 is a factor of this p of x, then one root could be negative 2. But let us see if one of the roots could be negative 2. Okay? So bring down 1. So we have 1. 1 times negative 2. We have negative 2. 0 minus 2. Negative 2. Negative 2 times negative 2. That is 4. Negative 7 plus 4. We have negative 3. Negative 3 times negative 2. We have positive 6. And negative 6 plus 6, that is 0. So since the remainder is equal to 0, therefore x plus 2 is a factor of the given p of x. And negative 2 or then negative 2 is a root of the given p of x. So it's checked, it's a factor. So negative 2 is also a root. So we have already two roots or zeros. Medyo naano ako sa root. Okay, anyway, root or zero, they are just simply the same. So 0, one of the zeros is negative 2. Ituloy na natin. Pero kung gusto nyo, kasi this is already a quadratic trinomial, then i-factor nyo lang. So, okay din lang. Pero kung gusto ninyong ituloy, let us see. I-try natin ang x plus 1. Okay, itry natin ang x plus 1. So we have, so this is x sub 2. X plus 1, from x plus 1 we have negative 1. Okay. So using again your synthetic division, we have 1. 1 times negative 1, negative 1. Negative 1 plus negative 2 plus negative 1 is negative 3. Negative 3 times negative 1 is positive 3. Negative 3 times plus 3 is 0. Again, since the remainder is 0, therefore x plus 1 is a factor, so negative 1 is a root of this quadratic function. Then from here, madali na. Kasi this is already x. Look, this is x cubed, x squared. So this is now the linear. This is already a linear equation or linear term. So this is x minus 3. Then equate it to 0. So x is simply equal to 3. So the last root, that is x sub 4, is equal to 3. So therefore, the linear factors are x minus 2 times x plus 2 times x plus 1 times x minus 3. So these are the linear factors of this p of x. So from the linear factors, we can have the roots, and these are 2, negative 2, negative 1, and 3. Okay? So I just hope that you did understand something about solving for the zeros of a polynomial function. So take note, as a summary, if we are to solve for the zeros of the given polynomial function, we are going to apply the synthetic division. The synthetic division will provide us the quotient, our q of x, such that the degree of the given p of x will be reduced one at a time until such time that we can have the quadratic term. Then from the quadratic term, we can have the linear term, which is very easy for us to solve for x. Okay, so that's all for today. Thank you for watching. I heart you.